Lesson 57, Operations with Small Numbers in Scientific Notation. Just a review of scientific notation. Your number has to have a decimal or a coefficient where there's only one decimal place or one digit to the left of the decimal point, and it has to be between 1 and 9. So more than 1, but less than 10. So it can be up to 9.99. And then it's multiplied by a power of 10, and the exponent can either be positive or negative. Since we're dealing with really small numbers, our exponent here is going to be negative. Adding exponents, so when we multiply bases, we add exponents, and when you divide like bases, you subtract the exponents. So just keep that in mind as we solve these problems dealing with scientific notation. So first example, if a sheet of notebook paper is 0.01 centimeters thick, how tall is a stack of 2,500 sheets of notebook paper? Express each number in scientific notation and perform the calculation in scientific notation. So let's take 0.01, put that in scientific notation. That would be 1 times 10. And I moved it 1, 2 to the right. So this is a negative 2. So 1 times 10 to the negative second. And I know it's a negative because my standard form number is less than 1. The other one, 1, 2, 3, so I got 2.5 times 10, and I moved it 1, 2, 3 places to the left. So it's 2.5 times 10 to the third. And then we multiply to find out what is how thick is, or how tall is the stack of those sheets. So I take 1 times 2.5, which is 2.5, times 10, and when we multiply like bases, we add the exponents. So negative 2 plus 3 is 1. So 10 to the first power, which really we could have this as 25. So this would be 25 centimeters. Next problem, a dollar bill weighs about 0.001 kilograms. What is the weight of $1 million bills? Express each number in scientific notation and perform the calculation in scientific notation. So this first one, put that in scientific notation. I know that it's 1 times 10, and I moved it 1, 2, 3 places to the right, so negative 3. Multiply this by, I got 1, 2, 3, 4, 5, 6, so be 1 times 10 to the 6th. I do my multiplication, I got 1 times 1, which is 1, times 10, negative 3 plus 6 is a positive 3, which would be equal 1,000. This would be 1,000 kilograms. Okay, next problem, solve and write in scientific notation here. So now we have a little bit more bigger numbers to work with. So 2.4 times 2, that would be 4.8. So always multiply your decimals by your decimals, or your decimals times your whole numbers. 4.8 times 10, and 10 to the negative 6th times 10 to the negative second. Add those, negative 6 plus a negative 2 would give you a negative 8. Now we don't have to put that in standard form. They just want us to put it in scientific form. The previous problems, we could write that in standard form just because it was, there really wasn't any bigger powers that you could not write it as a standard form. So here, 4.8 times 10 to the negative 8. Next one, we got 4 times 5, which is 20. 10 to the negative 6 times 10 to the negative 4th is 10 to the negative 10th. Put it in scientific notation, I need to move the decimal place. So it's 2 times 10. Since I gained an exponent, I need to show that I gained an exponent, or not an exponent, decimal place. So I put a plus 1. So it'd be 10 to the negative 9th. So our answer would be 2 times 10 to the negative 9th. With division, 2.4 divided by 2, so 2.4 divided by 2 is 1.2 times 10. And now I subtract the exponents, so negative 8 minus a negative 2 is a negative 6. Next one, I got 4 divided by 5. 4 divided by 5 is 0.8 times 10. This would also be a negative 6. But since I have to put it in scientific notation, I move it 1 to the right. So it'd be 8 times 10. And since I lost a decimal place, I need to show that I lost a decimal place. So I subtract 1, so that'd be 10 to the negative 7th. So this would be our answer. And a few other ones. Here we got 4 times 2, which is 8 times 10. 10 plus negative 6 is 4. So 8 times 10 to the 4th power. Next one, 1.2 times 3, which is 3.6 times 10. Negative 6 plus 3 is a negative 3. So 3.6 times 10 to the negative 3rd. Next one is 7.5 divided by 3 is 2.5 times 10. Subtract the exponents, so 5 minus a negative 2 is positive 7. And the last one here, 4.8 divided by 3 gives us 1.6 times 10. Negative 3 minus 2 is a negative 5. And final questions here, 1.5 times 3. 1.5 times 3 gives us 4.5 times 10. Negative 5 plus a negative 2 is a negative 7. 7.5 times 2 is 15 times 10 to the negative 7th. But in scientific notation, that would be 1.5 times 10. I gained an exponent, or I gained a decimal place, so I show that I do that with plus 1 in the exponents, so that's a negative 6. So just remember, when you gain decimal places, you add to the exponent. When you lose decimal places, you subtract an exponent. Next one, 8.1 divided by 3 gives us 2.7 times 10. Negative 4 minus a negative 7 is a positive 3. And the last one, 1.2 divided by 3 gives us 0.4 times 10. Negative 8 minus negative 4 is a negative 4. Put it in scientific notation, so this would equal 4 times 10. Since I lost a decimal place, I need to show that by subtracting 1. That would be 10 to the negative 5th. So this would be our answer. That is our lesson today on operations with small numbers in scientific notation.